Hello all, welcome to the show. I'm Gus Gagliardi and this is Fire Code Tech. On Fire Code Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Fire Code Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Welcome to episode 51 of Fire Code Tech. In this episode, we have Ernesto Janica. Ernesto is an electrical engineer, and on this episode, we get into some unique topics that I have not had the chance to cover before, like open source for fire and life safety and electrical engineering, and IEEE, which is one of the biggest professional societies in the world. I really enjoy talking with Ernesto. He has some great takes on learning for young professionals and professional development. Recorded this episode earlier in the pandemic and just got the chance to release it, but a really great episode with Ernesto. If you want to hear how to go from a technician to a registered professional electrical engineer and who has a great specialty in fire alarm and electrical engineering, this is a great episode. Really enjoyed it. Don't forget to subscribe so you never miss an episode and follow us on social media. Let's get into the show. Hello, Ernesto. Welcome to the podcast.
Good morning, Gus. How are you?
Good. So, I wanted to get started with your background and how you got into the fire protection industry. Would you tell me a little bit about that?
Sure. I think this was a casualty. I'm originally an electrical engineer, not a fire protection per se. And I was on site in one of the biggest projects in New Jersey at the time, where issues arise on the farm project, and I got to solve some of the issues. The company that was performing that work saw kind of my potential, I guess, brought me to the fire protection industry. But it wasn't my plan initially. I'm from a family of electrical engineers, so fire protection was not in my spectrum. But I'm glad that it happened. And the best things in life happen like that. So I got good friends and mentors in the industry, and that got me into the fire protection industry.
Very neat. Yeah, it seems like you are in the fire protection industry, but you've kept true to your electrical engineering roots and stayed involved with fire alarm heavily, and that seems to be where your emphasis is. So it's neat to see that.
Yes, the electrical portion of fire protection. I also have done many projects on chemical spectrum and the intelligibility of your systems. So mainly electrical, and then a lot of math involved, a lot of science, applied science involved, um, and that's part of what I like. It's a combination of engineering, math, science. And a little bit of luck, I guess. We all encounter projects very challenging where the solutions are not written in the books, so we have to be creative and develop solutions for our customers or for society in general.
Definitely. Yeah, I think we can all benefit from a little luck. I can resonate with that for sure too. And so, yeah, I definitely got into the fire protection industry with a little luck. So, yeah, I understand what you're saying.
It's a relatively a new career, a new field. It's not one of the core engineering fields where people were, growing up, they were being thought, oh, you're going to be a mechanical engineer, you're going to be electrical, you're going to be a civil engineer building bridges and stuff. So fire protection is kind of one of the newer ones. So, but we will see. I think now we have more, multiple generations of fire protection engineers. So, and the industry will continue to grow, hopefully. And I've seen very young generations motivated into these fields, and that's a great sensation when you see people engage into this industry. Um, just like we did it before, and we keep continue to engage in some of the aspects. There will be new challenges that uh, current fire protection engineers or old timers like maybe me or others won't be able to tackle anymore. The technologies will evolve, and we're going to need new set of skills and time, especially time. We're going to need the people to put the time and the efforts to solve those issues. So we'll see. I think it's a very challenging and promising career. So I encourage everyone that I know to go for fire protection engineering. It's a very very nice field to be in actually.
Definitely. Yeah, I have the same sentiment as you about just how promising the field is and how many opportunities there are for people to have meaningful work and to solve problems and to, be a part of a profession that is just, helping protect people and has an impact on life safety and just, quality of life for people. So it's very meaningful.
Yeah. Also the cultural aspects though. Sometimes we did like many projects in museums, for example, and you get to enjoy the protection of those type of properties and artifacts that they have a huge. There is no quantifiable value for those paintings or the structures there. Or so it is also a beautiful field where you can go and enjoy and work uh, for protecting not only people and businesses, but for cultural elements that if they get destroyed in a fire, um, then there is no replacement for them. So that's also one of the aspects that is very beautiful when you can protect a museum or art. That stuff, there is not many people working on those, but there is a few museums in every city. So hopefully some people will get a chance to work on them, and then you enjoy also those type of projects.
Yeah, I think, that's a great point about museums and protecting historical and cultural artifacts. I've been trying to do a lot of reading on fire protection lately and just, thinking about historic fires, thinking about most recently Notre Dame and, thinking about that situation and thinking about the implications that will have on fire protection in the future and how we look at historic structures and, cultural and, just buildings that have such value like that. So I think it's a very interesting point you make.
Yeah, definitely. But there was also a major fire in Brazil where the main museum was down to the ground and every artifact was destroyed. So we will never get back those devices or cultural elements that it's a shame. It could have been different, but you never know. It's just a challenge that we have to tackle moving forward.
Yeah, that's great. So I wanted to circle back a little bit about and talk a little bit about your just kind of the your early career. Wondered if you would speak a little bit about your educations and maybe some of the first roles that you had in fire protection.
By trade, I was my undergrad. I did graduated overseas and then I immigrated to the US. So I have both backgrounds in the US and overseas. I got my master's degree here in fire protection and I also have a master's degree in project management. So from my early careers and education, I like optimization. I like taking those courses and even as an electrical as a project or as a fire protection related classes. Those are the critical for me, or at least they were those involved in math, statistical analysis, algorithms. Now I also program like in MATLAB or other software that help you to identify fire criteria or other the type of elements that you want to design. Um, when I first started on this, I didn't start as an engineer. I guess that they didn't maybe believe or trust my credentials from overseas, maybe. So I was hired as a technician. I was helping someone else and driving a truck with a tool belt on my belt all the time, every day and night, doing on-call service and everything. The years, changing my tool belts and my skills to better serve this community. So from my screwdrivers and multimeters, and I still have the tool set here in my house. To be honest with you, I'm very proud and very happy that I did start like that. So I have that technical skill of fixing panels, troubleshooting circuits, seeing the issues with synchronization, or going through from multiple phases in a project. So I didn't start like that and evolved to being CAD drafter, helper, then to be the engineer, then the project manager, and then you know senior consultant, and so on and so on. So I did not start applying to a job in the internet. There was no such much thing as the internet back then went, or the job search back then went. So no resume for me for many years, and I did stay for in that company for several years, maybe 8 years. So very grateful for the people that mentored me there, many technicians that helped me to understand the basics of firearm systems. And they grew me. They kind of, there was a lot of like internal training for programming the panels and the sequence of operations, how you embed the codes and regulations into the programming part of the equipment, and how that works. Elevator recall. Nowadays it's just one X that you mark in the matrix, but I know back then when we were doing programming with the basic logics in the program, interfacing with the devices, going into the field, installing those devices, so troubleshooting them as well. So a lot of work, and I did work and study at the same time when I went to the University of Maryland for my grad school, my grad degree. So it was very challenging. Only a few hours for sleeping, and then going back to work, and a few hours of sleeping, and then going to the books, and so on and so on for several years. So it took me probably double the time, but I got my 4.0. I got a patent application out of that, and a lot of friends in the road that I'm very grateful that I met, and they taught me a lot of things.
Wow, that's an incredible story. I think that it's very meaningful that you had the opportunity to, see fire alarm installation in the eyes of the technician. I'm sure that has a huge impact on you now as you know, talk about engineering and, looking at engineering standards and, your role now. So yeah, that's really inspiring and very neat. Another thing you mentioned that I wanted to hear a little bit more about is you're talking about programming the panel, and you're actually doing programming. I program a little bit in my spare time, so I was just for my own curiosity wondering, you know, what kind of language does fire alarm panel use, or is it yeah? Could you tell me a little bit about that?
Well, most companies use proprietary programming setups, but it's basic logic. Once you understand what the logic is, it could be a C++ or a PACnet or whatever logic is, even MATLAB. Um, so they all follow logics. So once you understand the logic behind, and then you are able to program. The main challenge is when you go to an existing site and you have to reprogram something because you have to follow kind of the logic that was used before. And there are people that can program really easy and direct, and there are others that will put more equations into it or more algorithms into it. So you gotta get familiar with people that are more complex or the ones that are simpler. Mainly, if you can program basic algorithms or basic databases as well, um, then you're good to go for the different manufacturers. So it doesn't matter who you work for. All follow basic logic, but they all use proprietary software, I believe. Unless now we have something that is open source, but back in my days, every company was a little bit different. But again, it's just math and logics.
That's very interesting. Yeah, that makes sense that they all kind of follow the same logical operators. And, I have experience with the fire alarm input output matrix, and I could understand how that could be construed as logic. It is logic, and it's.
Yeah, it's similar. You have to actually translate from the matrix to the programmer. So that's basically what the technicians will do regarding to programming. But you also get your training. Each company has to certify you for the different levels of training. So you start with the small panels, no audio, then you go for and then you have to go for the classes, take tests, and if you pass, then they allow you to do another project, and so on and so on. So it takes you quite some time, a couple of years, and hundreds of projects. We used to do maybe 120 projects a year. So it takes you 500 projects to know a little bit on these things. You won't know everything, but you get sufficient to solve many problems. So it takes a while, but again, it's great to work with these guys. I still receive calls from my fellas as a technician. They do on call service, so they call me in the middle of the night. They have this emergency. What can I do? What the standard says. They kind of trust my judgment on a few things, and I do trust their judgment on other things. So we go back and forth. Even I haven't worked with them for maybe 10 years now. We keep calling each other, and we visit each other. We try to be friends, and it goes beyond just the job, just uh, friendship and the trust. You are working with these people for years, or protecting people or chemical plants or stuff like that. You do have to trust them. Or the professional skills at the personal level as well. I believe that's how I work.
That's awesome. That's really interesting. Yeah, it's you know I think any industry is about relations, but especially in fire protection, where you're trying to help these people ensure life safety in a building. There's an even bigger connection there. So that's neat that you still stay in contact with those people.
Yeah, I'm grateful for that too. They became my family actually. Yes.
That's awesome. That's really cool. So another thing that you touched on when you're talking about your background is you're speaking a little bit about your patent for the fire alarm industry. I was curious about that. I think I read a little bit about it on your um, LinkedIn or your bio somewhere, but yeah, would you tell me a little bit more about that?
Well, yes. This was a performance-based design application for strobe lights. Um, we had a major project where we were protecting millions of square feet of retail space and common use space. One of the main, it was the biggest mall in the U.S. being built. We had some issues with synchronization, which we fixed in the field, and the other one. So we were not, we just contractor installing the devices, right? We were not part of the design team or anything, but I was, doing my grad school at Maryland. So I did say, you know what, we could reduce this using performance-based design. We could optimize these resources. So it's several analysis there, send it up to the chain, and they say, no, you're crazy. How you guys are going to do it while the main senior consultants haven't put this in the drawings. But maybe that wasn't part of their project anyway. But that was the challenge that we had. Millions of dollars invested, maybe more than $20 million actually at the time. So kind of like a big project. So it was basically a math application of the codes and regulations. The main standard that regulates firearm systems. It's also based on other requirements. So we went back to those initial requirements, the UL listings, the initial lab tests, and then perform calculations and estimates. And we also had the field devices to test and work, having 2 or 3 Christmas times in these containers, working in winter locations. So we were like, let's keep doing testing and see how can we improve this thing. So we did that. It came out that it wasn't developed before, so we submitted for a patent. And I did many technical presentations on this topic. Once the company allowed me to do it, this was through the manufacturer that I used to work for. So they kept that, and I think they're using it for their existing devices now. So if you combine that with maybe power saving capabilities or other patents, in other words, you're gonna save millions of dollars. And in that specific project, for example, just to give you an idea, you we were able to go back to the owner, and this wasn't easy to do, but we went back to the owner and said, you know what, we can save you $2.3 million, for example. So that's kind of the scale of the savings that you could do in a major project. So some people were not happy, like, how are you going to put, send money back to the owner? Don't worry, and then we get hundreds of clients more. So you do good, and the good will come back to you. So we put money back, and then we got hundreds of clients saying, you know what, hey, can you do this for me? Can you do this for me? We also got a really good relationship with the designer of that project, which was a major player at the global level. Yeah, we were not just playing in Jersey anymore. We were playing at the global level with these great names, great engineers, great people to work with, and they say like, "Whoa, it was a really good experience with win-win situation for everywhere." Yes, we reduce our project size or cost, but then we also gain so much, so many friends, so many clients, so many interesting projects where we were able to apply these concepts. So that's a little bit of, without going into the technical details or the legal aspects of it. I think that was great, and it opened the door for me, especially as a person or as an engineer, and also for our company to be out there. And I kept these friendships, as I said before, before it was at the technical level. Now with this senior principal engineers, then it's still valid today. So, and this also was like more than 10 years ago. So.
That's great. Yeah, that's really interesting process. And it sounds like you got creative, and an engineer's role is problem solving, and it sounds like you were trying to build a better system, even at the technician level. So yeah, it's kind of strange, the implications of people get a little bit bent out of shape about calling somebody an engineer. But I mean, the functions of what you're doing, helping to design the system at that level and making it better. I mean, you were already there in my opinion. But yeah, that's really fascinating.
Yeah, and imagine the challenge that like a little guy like that calling your boss or your boss and say, hey, let's put over $2 million back. That's that was a lot of trust that they put on me, and I remember my boss at that time. He's a really good friend of mine, Mike. Uh, I think he put a lot of trust on me, and he shows. And after decades of friendship and working together, and not together when we work in different companies, I think that we do trust the judgment of the people when you are able to say, okay, this is something that we can do for you, and then you say, okay, yeah, I believe, I do trust that their solution it's looking for the better system or for the client's benefit or for the society benefit. So you start building these relationships with people that do really care. It becomes easier. We did, different projects like correctional facilities, more difficult environments, but you are, shoulder to shoulder with people that you do trust, and they know that you're going to do the best for society. So that's how I think you build this thing. It's not only for solving the technical aspects, but to solving the stakeholders' issues and boundaries. When you work together with the stakeholders, then you get these things to make these things happen.
Yeah, I can see that. So I wanted to get a little bit of a picture of your role now with the IEEE, and yeah, I'd like to hear more about what you're doing now, and yeah, your role.
All right. Well, that's another passion. Being an electrical engineer, I've been an IEEE member for many, many years. Even when I was a fire protection engineer, I always kept my membership for IEEE. For those that don't know, IEEE is it was initially the Institute of Electrical and Electronic Engineers. Initially for those professionals in those fields, but now we have hundreds of fields like nuclear, radio operations, IoT, uh, the 802s, the Internet. The Wi-Fi was developed here in my office maybe 25 years ago. The Ethernet was really, 40 years milestone. So a very passionate group of people. When I decided to leave the industry, the private sector, in fire protection engineering, I did went to work for an SDO, a standard development organization, developing the standards. Unfortunately, I couldn't relocate to Boston. So I came back to Jersey, and IEEE offered me this position where I do work for the Standards Association, which I like, developing standards, but I do work on the product development uh, part of it. So we have about, back again, IEEE is the biggest professional organization in the world. We have over 425,000 members in 190 countries. Let's put it that in perspective is maybe SFPE has about maybe 10,000 members, NFPA maybe 25,000, 30,000, 40,000 members maybe, and we have 425,000 members. So we have a lot of people, a lot of professionals, experts working in these fields. Um, we do have about 16 to 1700 standards, and my job is to create new ways of presenting this information, getting the handbooks for the main standards, educational programs. Can we develop mobile apps solving the equations within the standards? Um, and any other, or maybe databases to analyze data sets for developing these standards or for the public to use. So we have many products to address those needs. So that's what I basically do, trying to develop new ideas and new products for these standards.
Very cool. Yeah, I wasn't aware of IEEE, as crazy as that sounds, before I came across one of your articles on audibility and intelligibility. And, I was working on a project and I was trying to understand better, how to lay out voice devices. I was working on a mass notification system at the time. But so yeah, after doing some research into you and your background, I found out about IEEE, and man, that's really neat that there's such a large organization with so many professional members, and that sounds like a great thing. I wanted to hear more. Oh yeah, I just wanted to hear a little bit more about some of the types of standards that you guys produce. For people who don't know, what would these standards pertain to, or when would be a good time to go take a look at them and look at some of the resources like that.
Well, it's a broader aspect. Though we, as I said, mentioned, we have 16 to 1700 standards. So about 40% of them are from power and energy, meaning like nuclear power plants, maybe some aspects related to firearm systems on battery and energy storage systems, both for like the vehicles or for our backup powering firearm systems. So we have a standard for almost everything. Again, the Ethernet, it's a big collection of standards. The IP addresses is also part of my group that we manage that for society in general. we are not a super big company. We but we have a big number of volunteers doing a lot of the work. Um, so some of the important standards are in IoT, Internet of Things, Power over Ethernet. That was probably one of my latest presentations related to firearm systems. So what I try to do sometimes is to bring those type of technologies into firearm systems. For example, there is a lot of information in our databases, in our libraries. If you are a member, for example, and we have student members also that they some of them are free or they are like the charge is very minimal and you get access to our libraries. And Explore is the name of our main library, and it has over 5 million documents. So, for example, when I was doing my patent research, I did read I don't know, maybe more than 20 articles from IEEE. And the same happens today. Somebody asks me about any specific technology. The first thing that I do is go to Explore and check what I need and read a few things there, and then you get the top scientists around the world. These people that are everywhere, not only like government focus or one country focus or one region focus. This is people from everywhere in the world looking these problems from different aspects. So when you get that sense of input, so that type of input that you get input from everywhere, and different type of backgrounds, you get a better rounded, output. You get a better sense of knowledge, I think. So that's what we do basically. And I think IEEE at one point was producing about 70% of the technical content in the world. So we are referencing patents maybe 3 times more than any other institution. So basically, because we have many conferences a year, many publications a year, depending on your industry. For this specific aspect in firearm business or fire protection, I will guide you maybe to Industry Application Society. Is the one that I belong to actually also. So I may be a little bit biased, but it's the one that is kind of related to what type of devices do we use in the field, because any device that we have there, inputs or outputs, monitor devices or the relays and the IO devices, whatever you want to use, or even the 24 milliamps relays that we used to have before, they could be improved. And how do you improve those technical devices that are like electronic circuits? Okay, go to one of those technical societies and you get a lot of feedback on how you build it. Nowadays, we're also working on open source, and the product manager will report to me actually to develop products on platforms. Uh, we call it opportunity. We don't call it products per se because we are a non-for-profit organization. But we are looking into also how we develop multiple tools with open source software or devices that could help communities everywhere. So our main focus is advancing technology for humanity. So if we can make it happen, we will make it happen. And that's our main motivation, is keep advancing technology for the benefit of humanity.
That's really interesting. I've heard of open source a lot in the field of technology, or like I said, getting into programming. There's a lot of open source, but I've never heard of open source in the context of electrical engineering or fire protection engineering. So that's really interesting to hear you talk about that, and trying to make resources more available for people.
Oh yes, we already have a team almost ready. We have people that have come from the private sector for startups. With this set of skills, we're looking for one more person to move forward with a few of the initiatives that we already have. So yeah, but we can. That's our main focus. One of our main focus is one of the focus. We have so many projects to do, but this is one of the important ones that we see in the future. Let's start collaborating and let's put some of these tools. Because we also do, IEEE does a lot of community service and a lot of projects in underserved communities where we can send the devices of these open source platforms or software and help them build, I don't know, water resource level or middle level system or an alarm system or earthquake sensors, stuff like that. It's just, using that type of technology for the benefit of humanity will require most probably open source. And that's our goal. It's just how can we make all this available for free? The 802 standards, all the Ethernet standards, we publish them and we charge for them, but after 6 months, we make them available for free. So because we want the community to know how to use the platforms or the tools or the requirements, so every manufacturer, every company that is building devices are able to be compatible with everyone else. So that's one of the roles that we play in the field. We're grateful for that, and we have a lot of people that support those ideas, and we will continue to do as much as we can.
That's really interesting. I like that. That's kind of the whole reason why I got started with this podcast is to try to make information about fire protection just more accessible. And so, yeah, that's really neat.
Yeah,
Uh,
and this also will bring opportunities for the fire protection industries. If people, for example, before we were talking about the programming tool for the fire panels, if that software will be an open source platform, for example, that initiative will come from anybody in the fire protection industry and bring it to IEEE, SA, the Standards Association, or to any other organization. Hey, how can we build this, cross-referencing thing? But then you get into IP, the intellectual property, and the patents issues and stuff. So that may be a little bit more challenging. But if you want to develop something that is completely open source, please look for the opportunities out there for the societies that are trying to promote this. The Society of Fire Protection Engineers is also a great tool. NFPA is another super great tool. They all doing their best, but we all have our limitations. Time and effort and money, uh, but mainly time. Though it's just like I was talking to someone else before, and I think our main challenge will be to manage our time, and the projects that we have, and how we focus in the specific topics that deserve more time. Because it seems that we won't have time for everything, and especially nowadays, with the coronavirus challenges, I think this is an important point of human history where we have to also focus on how can we improve these medical devices. For example, we have actually has many initiatives now on how can we develop respirators cheaper or free, or can someone donate the drawings or the IP to do this. So that stuff, it's going to take a lot of priority at this time. Some of them, just to give you guys an idea, some of those tools, I cannot go into the specifics because they know the patents that we are working on, or I'm working on, is that there are some of those technologies that are for fire protection industry that could be helping other people in the medical fields. So there are many opportunities, and once you get a grasp of what you can do, then you will never have enough time to do all of it, because you always have new ideas and new projects and new ideas and new projects, and that's the challenge, though. So hopefully we will help some people and guide the new generations to do more. That's what we are here for, trying to motivate the people to continue researching, creating new tools, solving new problems, because that's what is going to happen. You're going to have new challenges and you need new solutions.
I like that. That's great. Yeah, I definitely see what you're saying about once you start to peek under the hood at, trying to look at new and better ways to solve things, it just kind of opens up Pandora's box and, there's just never enough time for all the, you know, different problems you want to solve or, new methods you want to try. And so, yeah, I definitely hear what you're saying about that. But, uh, yeah, I wanted to transition a little bit. I know that you have a specialty in fire alarms, so I wanted to pick your brain a little bit about some of the trickier areas in fire alarm. Or yeah, I just was wondering if you had any advice for learning some of the more difficult areas in fire alarm design, like. I know that you have a heavy influence in math, so I didn't know if you had any tips or guidance for professionals trying to learn about calculations or just fire alarm design layout or anything like that.
Okay. Um, yes, I will recommend everyone to start with the codes and regulations. Whatever the code and the standard says to do it, just do it that way for for a good time. I mean, when you become familiar with that, with the standard, probably 80 to 90% of the projects can be solved with that set of recommendations or requirements. That's called like a prescriptive code or design tool, right? Where the code is going to tell you this device has to be here at this distance, this far away from this ventilation system, XYZ. So each device actually has a requirement, a prescriptive way of doing it. Just do it like that for until you are really, really familiar with that. Um, then you could explore into the performance-based design. So anything that you think is a gray area in the standard, it's an opportunity. Um, in, Look at the annex material in the handbooks, for example. I'm just referencing the main fire alarm and signaling code. Uh, if you go to those documents and the electrical safety code has the same in the handbooks, look for the handbooks mainly. And then the annex material will have additional information about how the heat detectors operate, right? That could be basic now. There is also calculation for audioability, audio or intelligibility as well. So those aspects are there for a reason. They are not in the code yet. They may come into the parts of the code. So they leave the annex and become part of the formal code or the standard. The annex usually is not part of the code or the standard as an enforceable regulation. So for those that don't know standards, but the annex is just like additional material there, right? So look for those and look for the opportunities there. If you have the skills to do math at that level or at a more advanced level, then you're going to have great opportunities to develop your own things and to be successful at it. So that would be my recommendation. Start with the regular standards, work on them, I don't know, 100 projects a year, do it for a few years. And then you become like really quick and you have seen almost everything. Or the main challenges if you work for uh, correctional facilities, federal courthouses, or public school, or malls, or hotels, then you're going to have a good example of a little bit of all the fields that or occupancies that or clients, different type of clients. If it's a government, if it's federal, if it's the army, if it's overseas, stuff like that will give you a really good background. Once you have that, I think it's easier to go to the performance-based design. But I will not recommend a new person in the field to go directly to the performance-based design because those are, I think, meant to. And this is my personal opinion. I work for standard developing organizations, but I do not participate on the working groups. This is only my personal opinion. It's not their recommendation. I think those performance-based design elements are there to solve the unique environments, triple high atrium or smoke control systems that are not, in a square box. That is when you're going to need those type of skills. And once you have that, everything else is easier though, or become more fluent to you. So I think you have to put your time. That's for sure. This is nothing that you're going to practice 20 minutes a day for like 3 weeks and you're good to go. No, it's going to take a couple of years or maybe more than that. So just be patient and be thorough, be detail oriented, be math. So especially math, you have to have your background in math and science. Um, I don't know if I mentioned it before, but I do write books for kids, a math book for kids. So math for me, it's basic language. You could have a different native language, but if you are good on math, you're going to be able to explain your thoughts to any other person in the world, even if you don't speak the same language. But if math is the universal language, I think. So those are my recommendations at least.
That's great. That's really good recommendations. I like that. Get your fundamentals solid. Use the annex material and the handbook material. I just got a couple, um, the 2019 handbook for fire alarm code and for sprinkler NFPA 13 and NFPA 72. There's so much good information in those books.
Yeah, and
And
pictures, images that are not in the code. They show you stuff like, okay, this is the way of doing it. This is not the right way of doing it. So you see both. It's kind of in some cases, you see the examples of how you do it right and how you don't do it right. So you get like, oh, this is what it means. And then when that clicks in your mind, then you know it. Kind of it's like an internalizing the knowledge, and then it becomes like an easier, transition to do any other project. But you're like, oh, okay, that's what it means. Okay, got it. So, but it's difficult. Sometimes the codes and standards are really written as from a legal perspective. So, very black and white kind of thing. The contrasts are really there for a reason. But the handbook, I think, will help you a little bit more if you want to know what the subject matter experts think about every one of the regulations.
it's good stuff. Yeah, and I have a lot of interest in performance-based design, but like you're saying, I don't know if I'm at that point in my career yet where I am comfortable with doing a lot of those calculations. And also, they're not.
Yeah, you don't have to do everything though. Focus on one or two things that you're really passionate about it, because this is the fire protection industry is so broad now. It's going to be impossible to have one subject matter expert that is an expert on everything. So you maybe know one or two, three things, but um, don't try to learn everything because you won't be able to do it right. At least from my perspective.
Yeah, that's a good note. I like that. I like that. So I wanted to ask you about some professional development topics because, from my perspective, it seems like you have a passion for educating others and, yeah, just being a resource. I really resonate with that, and I think that's great. But yeah, I wanted to ask. What do you see as a meaningful trend in the industry right now? I know you've talked about power over Ethernet and Internet of Things, which are a couple big terms in the industry right now. But yeah, what are your thoughts on that?
Well, mainly for educational purposes, there's a lot of training out there already. I think the main players or the educational program developers will go now more into the online programs, because what is happening with the coronavirus outbreak, there is not too many face-to-face events anymore, which we used to do a lot of them. Many of the SDOs do it as well. So I think that's a new challenge, that transition of that content and information and the skills though. Some of these trainers, they do have their expertise in this field, so the face-to-face training was developed to bring that expertise to the communities out there. And I'm talking about everywhere in the world. We do provide training everywhere, almost everywhere. And the same with the other SDLs. I was also an instructor for NFPA 72 in many countries. So you want to bring this information to people that cannot travel long distances, or this is very expensive to come to the US or other places to get this training. So that's another challenge right now, and most entities will transition to an online program. Let's see how much can we do from the IEEE perspective. We maybe develop 10 to 20 programs a year. We'll see how many can we do. With this year may be a little bit different because everything is changing, but we will adapt and we will continue to do providing educational training. And also from my perspective as a fire protection engineer, we can do as many presentations as we can, um, and we will do it. We will do it through different organizations. Maybe this podcast is one of them, trying to be out there and try to bring hope and a connection with our friends and colleagues that need this type of educational program.
I think that's great. Yeah, there's really been an explosion of online learning opportunities and a lot of free opportunities, with organizations like SFPE and American Fire Alarm Association and NFPA and NFSA and AFSA. So there's a lot of great opportunities right now that people are trying to, still have outreach and normal content delivery. So it's been a really interesting time uh, to be a professional with all these resources being the flag being thrown up for people still wanting to converse and grow the industry.
Yeah, and I don't mention the individual SDOs, but yeah, every SDO is trying to do the best for their communities. Um, our members are eager to go back to India, China, anywhere in the world. Like hey, these people really needs to be proficient at these design systems, fire protection, you name it. Any other technology, it applies to every other technology as well. It's not only fire protection. So we'll do our best. Hopefully, there will be also like a group of people in the different SDOs working together and trying to kind of like put plans together or groups of classes together. Okay, this is the basic level for the technician. This is the next level for the next level of professional. This and don't try to replicate every content. That will be like a waste of resources, at least from my perspective. That you know we need to be smart also. We now with these limitations, we also recognize how vulnerable we are. Uh, with our resources, with our time, with our people that we get in contact with. So I think we have to be very smart to identify, okay, these classes are good, just keep it like that. Make an agreement with that organization and teach those as the basic requirements, and then go for the next one, and the next one, and the next one. You may find a few different ways of teaching one class, but the basic concepts should be basic concepts everywhere. So I will try not to reinvent the wheel if we can, and just get the fundamentals right, and then look for those performance-based design classes. That could be a little bit different in every technology, but uh, don't try to make 20 different classes on the same topic, because then it's just a waste of resources, I believe. And the communities also get overwhelmed with the amount of emails or invitations to classes and stuff like that. So we have to be very careful with those elements as well.
Yeah, I think that's a great point you make about the global state of fire protection and just uh, having resources that can reach all around the world. That's something that I have a lot of interest in, just because I don't understand how codes and standards work in other countries. I was reading about Australia and Japan last night, and how they're a little bit about how their model codes work, and it's interesting. I really like the idea of a fire protection class or some sort of resource that would be helpful to anyone, despite the fact that their model codes and standards might not work in the same way that the U.S. does, or that another country that follows the International Building Code. But yeah, I don't know what your thoughts are about that. I wanted to ask you just about, your global sense of fire protection and maybe some of those resource things too.
So all the codes and standards are evolving documents. So they will evolve no matter what, depending on the technology, depending on the challenges, depending on we get a new chemical products or gases or pyrophoric materials that need to be especially the firearm system or the fire protection system has to be specially designed for those type of challenges. So that's going to occur no matter where you are in the world. So the basic codes and standards are mainly guidelines depending on the type of infrastructure that you have or the buildings that you have, the occupancy that you have. So they may change between countries and countries or regions, right? So I will not see that as a main issue. I think those can happen no matter what. But if you get your basics, the fundamentals done properly, smoke or fire or chemical reactions or spectrums of light or the levels of variability and intelligibility, those are more easy to get acknowledged to or uh, an agreement on from people anywhere in the world. And we have done projects in China with audio and everything, so many contractors came from Australia to develop those installations. So, same with Japan and all that, if you're talking of some of the military bases there as well. So, same regulations, applications a little bit different. Um, so I think it's gonna, the difference between regions and stuff, it could happen, but once you have the fundamentals ready, then it's easier to adapt to the local regulations. That would be my perspective. You will adapt to projects like in the same in the US. You have 50 states, and every state has a little bit different regulations. Maybe half of them are the same. But then once you adapt to the basic, okay, give me what's the difference. What's different here? Okay, I do it. So the basic concept should be based on math, science, and technology, right? The other ones are more like regulatory or legal implications, liabilities. So that's where you're going to see the difference. Maybe body calculations, same applies for everywhere, but your levels of body calculation will differ based on the local regulation or the insurance company that is protecting that location. So, but if you know how to do body calculations, it doesn't matter. They tell you 24 hours or 48 hours, it doesn't matter. 60 hours, you put a number, you do your calculation based on that number, and you're good to go. So that will not be the challenge for me, at least from my perspective. You get the fundamentals ready and then get the local regulations to see what's different.
Yeah. Yeah, you're exactly right. I mean, fire science is fire science all around the world, and fire chemistry is fire chemistry, no matter what language you read it in. And so, I like what you said about math and science are universal languages, and yeah, the fundamentals. Understanding, needing battery calculations or needing pressure and flow requirements for a sprinkler system is the same no matter where you are, despite the jurisdictional differences. So, yeah, that's really good. I like your take on the fundamentals and building resources for people to, you know, understand the basics of fire protection engineering. So, I wanted to end with a topic that has been on my mind a lot recently. Uh, Energy storage system seems like has been a big topic of discussion in the industry with lithium ion batteries and thermal runaway and that sort of thing. But yeah, I just wanted to hear your thoughts about energy storage systems and how you see the fire protection industry is going to change to address these new hazards, and yeah, what your thoughts are about that.
Well, I think that's one of the areas that is going to continue to get bigger and bigger. And more research is going to be done. But I'm not an expert on the energy storage. So, uh, I have read a few things, but I'm not that deeply involved into it. I apologize. I don't have a lot of feedback into it. Just because that was not the type of project that I was doing.
Oh, that's okay. Yeah, I'm no subject matter expert on batteries or energy storage either. I just, yeah, it's interesting to me to look at those type of problems because I'll be designing fire protection for occupancies with battery testing spaces, or where they'll be storing racks of batteries, or just these rooms, and thinking about the different hazard categories of um, nickel cadmium batteries and lithium ion batteries. And I've read some interesting articles recently about you know fire protection on airplanes, and how thermal runaway of lithium ion batteries in like the cargo bay of airplanes is a really big problem. And Yeah, so I mean that's kind of where I'm coming on, but I understand it's kind of a out of the blue topic. But yeah, I think I've just been
Yeah,
thinking
no,
about it a lot recently.
yeah, no. At least for me, I didn't work in those fields or the wildfires, for example, very important in California and other places too. Australia also had like a major fires recently. So wildfires is another big topic like that. Like how, and I was surprised also when I went to the University of Maryland, I think like last year or the year before, and I saw a lot of students working on that field, and I'm like, huh, amazing. It's just like different challenges, though. We will see that coming, and once the technical barriers will be solved, though, there will be uh, chemical people involved, fire protection guys involved. Developers involved. So the technical aspects, I think they will be solved um, at some point, and we need to put that into the regulations. The codes and standards, again, I go back to my roots. It's just consensus-based documents, right? So we need the feedback from all these experts to be able to build something that it's okay, or at least the baseline for designing systems for the energy storage as well. So you just need a lot of people to develop something like this. Maybe 150 people I will expect to be working on one specific topic. So if you want something built or an agreement on kind of like a design guidelines or standards or how to better design systems, you name it in any type of industry, you're gonna need the working groups and the SMEs, and you need probably around more than 120 people to do it in order to make it happen well. I think there could be smaller groups or task groups, task forces to develop a specific databases, how they track the existing fires. The data is out there. If they have the data, or the owners or the manufacturers have the data for the battery storage, for example, the airplanes, for example, that you mentioned, all that is a collection of data first. And that data has to be analyzed in order to get a good fundamental data set or analysis of that data to be able to build on it. So because back in the day, most standard didn't have that technical capability or that data set as a fundamental because they didn't exist. We didn't have sensors for everything back then, right? So there was no data sets. And now we're getting more data sets to be able to do the calculations and say, okay, you know what? Safety distance is 3 feet and not 4 feet. Stuff like that will improve with technology and with the proper SMEs as well.
Without a doubt, yeah. You talking about data sets brings to mind. I think FM just released a good paper on energy storage system, and yeah, they were talking about separation distance being one of the biggest factors for limiting fire spread to other modules of energy storage systems. So yeah, I think you're right.
Yeah, we're going to see that more and more. Data driven elements or equations or analysis where the requirements, the codes and the requirement will be based on. Before it was more about the good engineering practices, what people thought it was good or safety enough, but now we're getting more into data analytics, processing that data. It's crucial for having a better sense of what is okay, what is a safety requirement, what is the proper voltage drop regulation, stuff like that. The more data we analyze, the better that output will be if the data is processed correctly. So I think that's one of the aspects that some people will be moving into it. Not a lot of people get excited about the standards and processing that stuff, but one or two that work on this aspect will be okay. Not everybody has to work on the data sets, but a few people that do it, and then the regular SMEs will do the analytics on it. And that's what we all need to put our expertise together, and we do little by little to get a consensus based document out there.
For sure. Yeah, no, I get a little excited about the data. I'm not real good about reading all those I'll read the extract and the conclusion of some of those scientific journal articles, but it's pretty hard to get through a full 40-page document of talking about testing methods and all that. So yeah, but anyways, Ernesto, thank you so much for coming on the podcast and talking with me. I appreciate it. I learned a lot, so thank you so much.
No, thank you.
Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.